We'll start the day. I will start right now answering any questions you have, and then from there I'm going to work into, I did the answer key for the first electron configuration practice sheet I gave you in second period, so I'll upload that later on YouTube so you have that. And today, if you guys don't have questions, I'm going to do the answer key for the one I left you on Friday. And honestly, at this point, y'all are probably feeling like I am, that you're bored to death with this.
Nope.
I just help on noble gas.
I can get to
I have a
that.
question.
It takes too much work.
Okay. We can get to noble gases. Is there questions on anything else?
No.
Fantastic.
I just want to watch the videos tomorrow.
Yeah, that's what I'm gonna do.
Okay, so I will not be in here tomorrow. You will take the quiz. I'll try and grade it as soon as I can. But I have what?
Is it only 5 elections?
Yeah, you're guaranteed at least 5 on this. Guaranteed. All right, so in this, okay, we're going to start. I'm just going to roll through, and this is the sheet that I left you on Friday. Woo, baby. This is going to be long. All right, so let's start with orbital notations.
Oh, I think I read that. 86.
Yeah, radon's going to be a moment. All right, so in this, I am going to go rather quick. If you have a question, ask somebody sitting next to you or holler at me. I don't care. So in this, first one we're going to deal with is magnesium. This is how I tell the difference between the two. I didn't make a mistake on this magnesium. So in this case, I look at it, I make my stopping point. Man, I didn't even put this. So my stopping point in this case is 3s. It's in the third row, S block. And I got to show 2 electrons there. So in this case, I got 1s, which has 1 orientation, 2s, 2 orientations, 2p, 3 orientations. All of these are full. And I get to 3s, which is my stopping point. So I stop, look at my note. I have to show 2 electrons, 1 up, 1 down. Because it's all the way through. Sodium, 1 electron. Magnesium, 2nd electron. Periodic table tells me the information I want to know. Questions there? Fantastic. Magnifico. Bromine, topic number 35. Stopping point for bromine, look at the periodic table, is in the P block, so it's P. And in the 1, 2, 3, 4th row, and it's 5n, so I got 5 electrons to show. So in this case, I go all the way through the 1s, 2s, 2p, 3 orientations, 3s, 3p, 3 orientations, 4s, 3d, 5 orientations, and then 4p, 3 orientations. Everything is full until I get to the p, so we'll fill it. I have 5 electrons. This is the key. I will give you one of these to check you. 1, 2, 3, 4, 5. Make sure you follow Hund's rule. Alright? From the bromine. Sweet Jesus. Help me. Tellurium. Atomic number 52. Stopping point for tellurium. That goes in P, 1, 2, 3, 4, 5, so 5P. And it is 1, 2, 3, 4 N, so 4 electrons I gotta show. So, hit again, all the way through 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, which is my stopping point. I have 4 electrons in there, so it means it's full all the way to it. So we'll go on and fill it up, these electrons. Hope you all had a lovely, lovely weekend.
Oh, yeah.
You know, just making some small talk since I got to fill in all these electrons.
I don't understand why this week couldn't have been last week. You know what I'm saying?
Yeah. I completely understand what you're saying.
Like, why couldn't we have had 2 days off?
And make it at the end of the week be a great idea, but yeah. 5P for electrons. So, 1, 2, 3, 4. Questions?
Are you videoing this?
Yes. I'm videoing it because it's the answer key, so please do not ruin my videos. No question?
No question.
You guys are doing fantastic. I'm so impressed. You'll do it.
Are you gonna put ones on the test that are like RN, it's like 86?
Please.
It's like
Yeah.
102.
Absolutely fair game.
Oh, come on. That takes up half the page.
I don't take me the whole class to just sit there and write that out.
I will tell you this, chances are, unless somebody like utterly just ticks me off, which nobody has yet, so y'all are safe, I won't give you like one of those that's long for an orbital notation, because like that, I mean like right here, that's really stupid long. Now electron configurations, I absolutely could, because it doesn't take that long, because you're just writing down numbers, letters, and that's it. Noble gas configuration, absolutely. But pretty much orbital notations, like I really wouldn't want to do tellurium because it sucks to have to grade tellurium. But I will give you something that actually makes you, like, I need to see that you understand that you go from 4S to 3D. It drops in energy. I need to see that you understand that. I need to see that you understand that you have to show the spin. You need to understand why you got to show that spin. Why is the spin important? The spin of the electrons create a magnetic attractive force that opposes the natural repulsion force from the like charges of the electrons. You can write that, and it's in the video. So, there floats your boat. Tellurium. We finished with it, so now we're on to iron. Iron is atomic number 26, which will end in 3D. Is it 6 N? 1, 2, 3, 4, 5, 6. Gotta show 6 electrons. So we got 1s, 2s, 2p, 3s, 3p, 4s, 3D. Everything's full until the 3D. And in this case, we got 6 electrons. 1, 2, 3, 4, 5, 6.
Has anybody ever made a 100% in your quiz?
Yeah. I've had 100% this semester. Typically, I'll be honest with you, this quiz right here is one of the highest averages we get.
I figured you'd say the hardest because you pull some tricks on us.
Mm-mm. I'll even show you my tricks that I normally hold on to. I did it today. And big long dog.
Tricks on us.
Radon. Radon ends in 6p, 6 electrons. I'm gonna be a minute.
Take it.
1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f,
And
5D. Yeah, you go from 6S to 4F. 6S, 4F, 5D. 1, 2, 3, 6P. I'll meet y'all back down there at the end.
you judge me. Oh God, I bet you did
I think it's as you go back to the D, right?
Do what?
Like after you do, like after you done four. Yeah, I'll say it. Or not.
What? Alright, finally there, I made it all the way back to 6p. How many electrons shown in 6p? 6. So, 1, 2, 3, 4, 5, 6. Done. There's radon. Any questions there?
Yeah, can I get stuff real quick? I didn't get this one.
Is that all gonna fit on the video?
Yeah, you're good.
Okay, thanks. I'll just do that at home.
So it goes, everything's full, 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p.
I can do a rap of it.
Make it into a song.
Can you explain how it goes from 4F to 5D?
Look on your periodic table.
Yes.
Okay? Go 6s. So you end right there at barium. So barium's atomic number 56. What is next to it is a box, and what's the first number in the box?
57.
57. Where's 57 at? Is it next to it, or is it down below? So you're going to follow the numbers. You're going to go to 57 and go all the way through it. So you go to the F block. Then at the end of the F block is number 70.
So it goes back to the D.
Back to the D. Follow the numbers. That's why I chose this periodic table from this class from this point on. I want you guys. I want it to be simpler and easier for you guys.
Okay, I have a question. I haven't been here. How would you get the electrons? How do you... Like, I know the electrons on here already, but how would you figure out at the end?
How many there is at the end? I look and how far into that block it is. So, like for example, iron's a good example. I got 6 electrons because look at the D block. D block is columns 3 through columns 12. So starting at column 3, how far in does it go into the D block?
6.
So 6 electrons.
And then...
Before we
And
leave
then-
class, can you please go over Google Docs?
Yeah, that's what I'm doing. I'm doing electron configuration now. I'm doing that.
How would you put them I'm guessing it's
Yes.
Okay, so start
so
here. 2, 3, 4, 5, 6, 6
okay, so which one is
Like this one is easy. It goes 6 blocks. And you go all the way through the 6 blocks, so they're all filled. And if you were to go to the 4th, then
so you go from the nearest gas and you see how many sold in.
yeah, like the one that you stomp on, like say you stomp on this one, then 3 of the reactors just split and stay there, just because you don't go through all.
So you do the 3.
Yeah, and like down here, it's like the same thing. Because there's 14 from here to here. If you don't, and then you just stop halfway here, then these just split and then they're like if I just go up right here. And it's like that with all of them. You just count.
If you have one of the elements down here, and then you stop back in the middle.
All right.
I'll text you after.
So, a good opportunity here. I should have done this in second period, but I'm going to go on and introduce some trick questions to you. Because the trick questions are lovely. Normally, I hold this trick question and I put it in my back pocket until the next quiz, because then I'm like, watcha! But I'm going to go on and give it to you and let you know. Okay? What's your question?
Well, I was gonna say, can you not teach us so we won't have it, but never mind.
So it is. This is what you got. Here is my question. How many electrons can go into an orbital? Straightforward question. Every dash is an orbital. So what is the maximum number of electrons that can go in an orbital? 2. Very good. I'm very impressed with you. So 2 electrons. Are you ready for the trick?
You can.
You guys have got this. I believe in you. How many electrons can go into a d orbital?
-2.
Just 6. Wait.
10.
Does that mean D block?
Are you ready? This is why it's a trick. Because you all jumped from the number 10 and only one said 2. Orbital! Orbital. There is a difference. How many electrons can go into a d subshell?
10.
10 electrons. How many electrons can go in a s subshell? 2. How many electrons can go in a p subshell? 6. How many electrons can go into an f orbital? 2. F orbital. 2. How many electrons can go in an f subshell? 14.
How did you mastermind that?
This is how I'm happy you asked. How many orientations does an S subshell have? How many orientations? 1. S subshell, 1 orientation. How many orientations does a P subshell have? 3. P subshell, 3 orientations. How many orientations does a D subshell have? 5.
Then why are you putting 10 F?
Why'd you put
Never mind.
6?
10 electrons. What?
Earlier whenever you said
So how many
I
what?
never said S subshell in 6.
Oh, never mind.
I said P subshell.
What are you asking? How many orbitals?
F equals how many?
How many?
Orientations. Orientations. 7. How do I know how many electrons can go in that subshell? It's literally the orientations, which is just those orbitals in there, and you multiply it by how many can go in an orbital, which is 2. But I have no clue. What? Can have 6 electrons in it. These are electrons. How many electrons can go in the subshells?
So, like, the S equals 1, that's an orbital?
That's an orbital and a subshell.
Okay, so if you ask for a subshell, do we put 1 or do we put 2 for S?
That's what I'm asking you. If I ask you how many orbitals is in an S subshell, it's 1. How many electrons can go in an S subshell? 2. It's all about the question that's being asked at you. All right? Do not freak out. Normally I hold on to this information and I put it in my back pocket. But I am openly telling you now.
So you times it by 2.
To tell the number of electrons.
Okay.
Questions?
Wait a minute.
You guys can do this. As somebody said to me on Friday, I believe it was, when I was observing, they said, I guess we got the training wheels back on in chemistry now.
Oh, they just killed us. Oh my God.
Who said that?
I bet it was cold.
My mom said as long as I pass, I will not get grounded. I've never heard her say
Guys,
that.
all jokes aside, I'm gonna be honest with you. Like, the truth of it is you guys can do this. Like this, I promise you, this quiz is not that hard. Except for those of you that just have ignored it and just have not paid attention or tried on any of this. Hey, I'm working the answer keys with you and for you, and the answer keys are there, but you need to make sure you can work these. It's great that I can. I teach the class. I should be able to. What is it? Electron configuration.
Wouldn't that be 2p?
What?
Wouldn't that be 2p?
2p.
I'm trying to figure this out. So I'm working for 2p.
Here we go. The first one we have is Floyd, atomic number 9. So remember, with electron configurations, your starting point is always with hydrogen. You're going all the way through it, and whenever you stop, it's at the element that you're looking for. I'm not going to go over there on the periodic table and do all that. We've done so much of that. So I'm just going to roll through. So in this case, my stopping point, fluorine, is in the P block, second row, so 2P, and it's 5N. So 2P5, so I have 1S2. 2S2, 2P5. That's a horrible 5. Question?
Wait. What was it?
1S2, 2S2, 2P5. Moving from fluorine. Neodymium. Atomic number 60.
I got 2p, right?
Neodymium is down in the F. 6th row, so that means it's 4F. And it is 4N, so 4F4. Oh, we got the long journey ahead of us, ladies and gentlemen. Are you ready for this? Let's roll.
No.
1S2.
Emily Piner, Michaela Morgan, come to the office, please.
2S2.
Emily Piner, Michaela Morgan.
2P6. 3S2. 3P6. 4S2.
Like,
3D10. What?
No, come.
What do you mean slow?
well, I can't read what you're writing. 4S what?
2. 3D10. 4P6. 5S2. 4D10. 5P6. 6S2. 4F. Oh, that's my stopping point 4.
I thought you said you had a long road ahead of us. I was ready to write down 30. That's not bad.
That's pretty long.
Okay.
Okay, neodymium is gone. Uranium. U is for uranium. Bombs. Atomic number 92. We got this a little bit of a journey ahead of us. If you look at uranium, it's in the actinide series, which is in the F block, so we're going to stop at F. It's in the 7th row. 7th row tells me that it is 5F, and uranium is 4N. So 5F4, here we go. 1S2, 2S2, 2P6, 3S2, 3P6, 4S2, 3D10, 4P6, 5S2, 4D10, 5P6, 6S2, 4F14. Oh, 5D10, 6P6, 7S2, and 5F. Stopping point 4N, so 5F4. Bada boom, bada bing. Please listen to me whenever I'm saying. Do not just write down what I'm writing down and just say, okay, I'll get it later. I know what I do. I figured it out. I'll be okay. Now is the time to ask your questions. 400 over there. He's so bored right now. He's like, man, I am done.
Is it the same thing on these? Is
Hayden Morgan,
on
come
the
to the
top
office, please.
that
Hayden
credits
Morgan.
are supposed to add up to match the number?
Yes, absolutely. If you add the top numbers, these like exponent values, they will equal to the number.
Okay.
It's a good way of checking yourself. I don't like to do it.
That would cause confusion.
All right. Questions on uranium? Let's do krypton. Atomic number 36. A little bit of a journey, not so long this time. Krypton is in 4P6. Hopefully you're figuring out how I'm picking up my endpoint there. So 1S2, 2S2, 2P6, 3S2, 3P6, 4S2, 3D10, and 4P. That's my stopping point, and I got 6. Questions? No.
I have a question.
Yes? Oh, okay.
I'm just so confused.
I'm pretty sure it does.
Xeon. Atomic number 54. Got a little bit of a trek ahead of us here, ladies and gentlemen. We're going to stop right here at the 5P6.
And he's changing the Grinch.
So 1S2, 2S2, 2P6, 3S2, 3P6, 4s2, 3d10, 4p6, 5s2, 4d10, and 5p. Bada boom, bada bing, 6. Questions on your friendly neighborhood electron configurations? What?
This is what I need help with.
No questions on the configuration. Alright? Everybody look and say bye-bye electron configuration.
I think I know how to do this.
Do not come back.
But I'm not for sure, but that's okay. I got my friends to help me.
That's what matters. Is when you have friends.
Derek and Jordan Brown, come to the office, please. Derek and Jordan Brown.
Okay, here we go, ladies and gentlemen. The moment you all been waiting for. You all have been asking for it. By popular demand, Nova gas configuration. Yes, the excitement is in the air. Let's start with the sodium. Atomic number 11. In this case, here's what you always do. You take your finger, you put it on your element, you put your finger on it. You say, hey, yo, you nasty, dirty element, you. You go up a row. Put your finger on the element.
I can't find the element.
It's number 11, Christy.
Hold on.
So we're gonna have to.
All right. You went up a row, but now you gotta go to the noble gases. You have to go to the noble gases. So go to the noble gas, and what do you end up with? What?
The noble gas you end up at.
What column is the noble gases? 18. You must go all the way to the 18th column.
We're already in the 18th column.
No, you're not. You're in the first column.
Christy.
You drag your fingers in. So you start side.
We started
You go
here.
left.
Here.
Up one and over
I know I said I wasn't going to do this, but apparently everybody is confused. Hey, how's it going? How you doing? Thank you for watching our video. Like and subscribe.
Do not subscribe. Mr. Holland's not even on the screen.
Dislike it.
Hey, how about now?
Yes.
We there?
Yes.
Good?
Yes.
You're sitting right here. Yes or no? They're telling me yes, and you're right at it. All right, Christy, this is what you're going to do, and everyone else that's not saying nothing right now. You take your finger and you put your finger on it. Right there, sodium, number 11.
Yay.
You look and say, you dirty element.
So do we write down NA?
No, you don't write down NA.
Wow.
It's already wrote down for you.
No, I think I'm wrong.
Stop and listen.
Here's over to 18.
You put your finger on it. You go up a row.
Up the road.
Okay, I was
And you must go to the noble gases.
Is this for every single one?
Every single one. Hey, the 18th column. Here we are. Here's those noble gases. What element we end up with?
Neon.
Neon. If you can't see that.
Is that all we do is write down neon?
What?
Is that all we do is write down neon?
No, you ain't done.
Well, let's get the
Sleep.
Okay, this goes back to the gas.
Yeah, 18th column. Noble gases. All right, in this case, you take your element that you found, your noble gas, you put it in square brackets. So square bracket,
square bracket.
neon.
Just kidding. I won't.
Make sure and obey the chemical symbol rule. First letter will always be capitalized. Second letter will always be lowercase.
Is that all we do?
No, you're not done yet. You have now changed your starting point to neon. Okay, so you go after neon. It changes your starting point from hydrogen. So go away from neon. You go to what row after neon?
Wait, you have three. What are you talking
3.
about?
The third row. What row is neon in?
Why do you go there? You start on neon.
What row is neon in? It's in the second row.
when you go to
Okay, you start at whatever noble gas you find, and then you just go from there.
No, sodium is the stopping point. You're putting your finger on it because that's your stopping point. But to find the proper element, your noble gas, you just got to go up the road because it's the last noble gas you cross.
Freaking number 16.
It'll always be whatever.
All right, let's go to another one.
It'll always be.
Let's do sodium, atomic number 16.
That's sulfur.
Sulfur. I said sodium, I'm sorry. I looked at DNA and I was like, hey, that's sodium, yeah. So in this case, atomic number 16, put your finger on it. You dirty, stinky element. You actually, sulfur is very stinky. If you did not know that, it gives you the rotten smelling eggs. So in this case, we go to sulfur, go up a row to the 18th column. What do you get?
Ne. Neon.
So Ne, neon. Remember, it must be square brackets. From there, we roll through. From neon, we go to the third row. 3s2.
S.
Yeah.
What did the S?
So what?
You went through the
You
S
start
block.
from neon, and you just do from there. Like
So 3s2. Then we go to a 30p. How far in did we go into 3p for sulfur?
I don't know.
4. So 3p, 4.
number.
Let's do germanium.
We have 3 minutes.
We got this. We're using the shortcut. Germanium. What noble gas do we use?
Argon.
I want to go home.
Argon.
What's argon? Why do we use argon?
That's
That's the last noble gas you cover.
Wait.
So in this case,
Oh, okay.
What the fridge? How is that the last noble gas?
it's the last noble gas you cross because whenever you do the electron configurations of these, you'll find out where you want to stop at. Germanium, here's my stopping point. You drive all the way through hydrogen, helium, lithium, beryllium, all the way through all of this, and you stop here. What's the last noble gas you cross?
Argon.
Argon. It's the last one I got marked out. So now I choose here as my starting point.
Instead of starting with
So then I start and I come from here. I put that in square brackets to tell me that argon is the new starting point. And then I look and say, hey, yo, 4s. 4s2, 3d10, and 4p. Oh, I went 2 in, so it's 4p2.
America, it's fun.
Woo! 4s2, 3d10, 4p2.
How many questions will be on this quiz?
I don't know, haven't decided. At least 5. Platinum! Atomic number 78. Tell me the noble gas I will use for platinum.
Xenon.
Z-E.
Everybody good, it's Eon. Square bracket, XE, in square bracket. So from here, I actually got to look at this one. Hold on. So from here, we go to the 6th row, so 6s2. Then I got to drop down to 4f. Go all the way through it, 4f14.
Wait, I have a question on that.
Ask 5d10.
I'm coming for you.
And, oh wait, snap, it's not 5d10, it is 5d8.
I hope I don't stand with
Ah.
this. I don't have any ideas.
Me too.
And technetium.
Oh,
Now, Mr. Hall.
we're done.
Keep going.
Atomic number 43. For video purpose only.
I'm sorry.
Krypton? Yes. What is your question?
You finish that first and then I'll ask you.
5s2? 4d?
Well, I can figure my question out when we together.
1, 2, 3, 4, 5. We be done. What be your question?
I need you to listen.